Ladies and gentlemen, please welcome Peter Smith.
Thank you all for coming here on Friday. It's Friday morning, so you should all be fully rested from your great night's sleep after that party last night. So today I'm going to talk about 5 great reasons to use the new HttpClient API. And you might have guessed just from the title that what we're going to be talking about is a brand new API. It's not just some old API. It's not our existing APIs. It's something new, and something new in 8.1. It's called HttpClient, and it's called, in fact, windows.web.http HttpClient. It's a runtime component, and that means it works in C++, it works in C#, it works in JavaScript. You might also guess from the name HttpClient, it's there so you can connect your Windows 8.1 app out to a web service, out to a REST service, whatever kind of HTTP service you're talking to, we should be able to connect to it. When I talk today, I'm going to go over a couple different things. I'm going to give you an overview of what those 5 reasons are. I'm not going to wait until the end to give a big reveal. I'm going to tell you right at the beginning. But I'm also going to talk about what our object model is, the different classes in our family of HttpClient APIs. And you actually, those of you who are in the audience, you've already got a poster of what those APIs are, what those classes that we have are. I'm going to go through what they all are, which ones you're going to be using the most, with methods on them. We're going to do some coding on it to show you how they all work and how you can really get some value out of them. I'll be doing a deep dive of all of the different reasons. Then I'll wrap up by telling you how you can get started today with 8.2 with our new API. And so with no further ado, let's start. Oh, this is the right clicker. We'll get started. Whoa, that's the wrong one. I need the PowerPoint presentation, please. Thank you. That one will be a little bit later. 5 top reasons to use the new HttpClient API. And remember, this is the Windows Web API, not the System.net one. It's a client-side API, so you're going to be using it in your 8.1 apps. And when we talk about reasons, first one, shared code, cookies, and credentials. And some of you who have been programming in C++, using the IHR object, using in JavaScript the WinJS XHR, you're going to say, well, share. Well, of course it's shared. When I do my Atom Pub stuff, when I do my syndication calls, when I do my web view, when I do my image stuff, that shares the cache, that shares cookies. I mean, shared within my app, of course, not between apps. But if you're a so for those people, you're going to say, what? That's not new. That's old. But if you're a C# programmer, this is new. Because in the past, the C# API has not shared cache. Now it does. We have strongly typed headers. And this is the chance for the C# people to say, woohoo, because in C# 4.5 in the System.net HttpClient, you've already been able to do this. You know what the value of strongly typed headers are. But if you're a C++ developer or a JavaScript developer, this is new to you. And what it means is you don't have to set your headers with strings. You don't have to set the name with the string. You don't have to set the value with the string. You don't have to parse the string. You don't have to generate the string. Reason number 3, hello. Reason number 3, hello. 3, there we go. Access to cookies and shared cookies. And if you're a C++ developer, you've always had access to cookies with the IXHR2 interface. If you're a JavaScript developer, it's like, wow, I get access to cookies, same like everybody else when I'm making a WWA application. I got to point in that direction, that's why. And if you're a C# developer, you might say, well, I've always had cookies, but they weren't shared, they didn't persist. Now they do all that. You get control over caching in the shared cache. And this is new for everybody. You get a lot more control about when you make a call to a REST service, pulling down the data. Do you get it from cache? Do you get it from the network? Does it save to the cache? Does it not save to the cache? And lastly, you can inject your code modules into our HTTP processing pipeline. That lets you have cleaner, more modular code. If you're a C# developer, you've always had this with the handles. With the handlers. And if you've been using the Web API, you've seen how that powerful handler model really lets you write better code, with fewer lines of code, more modular, more testable. And we're extending that model to the C++ developers and the JavaScript developers. Now, before diving into some of the details of all these reasons, let me talk about our object model. And I want you to meet our family of objects in HttpClient. That's your code on way over there on the left. In green, that's your app there. That's your app that wants to make HTTP calls. It's going to use the HttpClient object. That's the #1 object you're ever going to be dealing with. That's when you make the GET request. When you make a POST request, when you make a DELETE request, you're going to be using the HttpClient object. It has on it 8 methods that we've defined. There's some other ones, like toString and getHash stuff. But we've defined 8 methods on it. 7 of them just named after HTTP methods. Get async, post async, delete async. In fact, actually, we like get enough. We actually have 4 different methods on our HttpClient object called get. There's get string async, get buffer async, get stream async, and of course, get string async. Now, what the HttpClient class does, what that object does, is it takes your call, it takes your request, and bundles it up into this neat little object called an HTTP request message. And the whole goal of this class here, this object that gets created, is to bundle your information, the headers, the HTTP method, the content, all gets bundled into one object so you can handle it in a nice, neat, properly object-oriented way. It goes over to the HTTP-based protocol filter. Now, this is what will actually send your data over the wire up to your REST service, up to your web service. It also, and the reason it has a little gear at the bottom of it, this is where all of these big settings are, or a whole bunch of the settings are. So if you need to control, if you need to have influence over exactly how you're going to call that REST service, that's where you set all that information. Now, after you make a REST service call, of course, you're going to get a response. And the base protocol filter takes that response, parses it all together, and forms what we call the HTTP response message, which, once again, is just a neat bundle of the response code, the status code, the reason phrase, the content that came back. It also includes your original outgoing request, which means you can tie stuff together. It means in your app code, you don't have to remember, well, I called something or other, and I don't remember my state now. You've got your state, because we give it back to you. The response message goes back to the HttpClient object, and then it just returns it straight to you. If you call like a get async, you get back this response message, all neatly bundled together. If you call get string async, we will actually paw into the content and pull it out as a string. Same with get buffer async, get stream async. We'll return it as a buffer, we'll return it as a string. It's important to know, by the way, that in all cases we can throw an exception. Why do we throw an exception? Well, because networks fail. All of you here at Build know how flaky networks can be here, at the airport, at the coffee shop, in the hotel, at your workplace, in your home. All these places can have networks that come and go. If we can't get a hold of that service, if we can't do the DNS resolution, if the SSL is invalid, we will throw. If the server is unable to form a proper HTTP response, we will throw. And in the case of get string async, if we do get a response, but it is not a 200 OK, or really anything in the 200 success range, we'll throw. Your code has to be prepared to handle that. Let's go see a snippet of code, and we're going to keep with the slides here. This is really the simple example of how to use HttpClient, because we know that overwhelmingly the kind of app logic you have is you know your URL and you just want to get the result back. So you can see we do HttpClient, get string async. What does it take? It takes a URI. All you got to do is make a URI, make the HttpClient, give a call. We'll return a string to you after doing the proper await stuff. This is C# code. We do the exact same kind of async stuff in JavaScript. We do the same kind of async stuff in C++. That's the advantage of being a runtime component. We always work the way runtime expects us to. So whenever you do an async and you're wondering how to do anything with the async pattern, it's the exact same async pattern that you would expect from every other bit of the runtime, from files, from displays, from scanners. Everything works the same way as far as async goes. And you'll notice that even in my simple example here, I'm catching my exceptions. Let's see a slightly more, let's dive into a demo here. If we can switch over to the demo machine. There we go. So this is my little demo app. It's got a picture of my developer on the screen. Now, as a PM, one of the things I do, by the way, is I keep needing to make demos with little pictures and stuff in them to make them a little bit more interesting. And I keep wondering, like, where do I get my images from? Where are my clip art? And I hate to just use clip art, and I can't go to like the free sites because they've got commercial licenses. And this, I believe, not a lawyer, would qualify as commercial. That image up there, that's actually not an image. That's actually Unicode character. It has a whole bunch of stuff in it. This is Unicode character, person with blonde hair. And let me show you the code that we're going to actually do. This is my other favorite thing as a PM, the flip view. I just have a bunch of grids in my demo program. I can flip between them. This is the code we're going to do. This is a little bit more advanced than just the get string async. This is going to call send request async. When we want to call send request async, it's more powerful, so it requires a bit more setup. What kind of setup? Well, it's going to take this request message object. Let me highlight that there for you. It's going to send this request message object. And you just new one up. And when you do that, you've got to give it the, well, what HTTP method do you want to use? We got a bunch all there for you, like get and post and delete and stuff. But we support basically all of them. You just got to do it yourself, right? You can use the webdav methods. You just provide a string of the method, and we'll use it. And of course, it takes a URI. Now, in this case, I'm also going to set a user agent header. And I'm going to set a user agent header because, well, otherwise, because unless I actually do something interesting with my request messages, I might as well just call it get string async. I'm going to set my user agent header in this case to test program /10. I know that that's going to work because I tried it and stepped through it. I know that's a valid string. Some server libraries actually require that you set the user agent. And indeed, there's REST APIs where one of the fundamental contractual requirements is that you have your own unique user agent. So in this case, I'm setting my user agent with my strongly typed headers. I'm going to pull my response out. I'm going to call get send request async. I've got my response there. Out of that response, I'm going to pull the status code and display it on the screen. And I'm going to pull the content out and display it on the screen. And let's try that live. And of course, as always, I catch my exceptions. So I know the URL I'm going to call. In this case, that particular URL, I think, goes to the US Weather Service. And I'm going to do a get. And it's going to take a little while, because, hey, there it is. That's the weather for San Francisco. And it turns out I did get a nice 200 OK status. OK, now let's go back to the PowerPoints. I want to show you what the 5 reasons are for using the new API. And I'm going to do more of a deep dive. So reason number 1 is HTTP integration with cookies, caches, and credentials. And once again, this is something that is not a surprise to any of you who are JavaScript or C++ developers. It's always been integrated. If you do AtomPub, if you do syndication, if you do a lot of stuff, if you use WebView, if you use image or media, it all shares image. It shares the cache, which means you can do an image tag to an image. But then also, if you do an HTTP GET and do that GET, you'll return it out of cache, probably, depending on, of course, what the server said. And again, if you're a C# developer, that's all shared with HTTP, with the Windows Web HTTP class. And once again, we don't share between apps, right? Obviously, there's no reason why any of our apps should share information with other apps on the system. If you're writing a banking app, it's very nice to know that your cache is separate from the cache of the games on the system. And we try to maintain that security for you. Reason number 2, we have strongly typed headers. It means fewer bugs in less time. Headers, in JavaScript, in C++, you've always been able to provide headers, but you've always had to do them as strings. It means you have to figure out what the name of the header is. You have to figure out what the correct format for the header is. And in all cases, it's important to remember that the only reason we do headers as client-side is to match whatever the server is going to require. Or in the case of a response, because the server is telling us something that we're going to have to know later on. The problem with doing headers as strings is it sounds so easy, but they're very easy to mistype. It's very easy to misspell them. It's very easy to get the parsing wrong. It's very easy to get the format wrong. The errors are really hard to spot, and even big sites make mistakes. This is actually an actual header from one of the big sites. I looked at it using the new API. I could dump all the headers. Premga. There is no header called Premga. Last modified. For those of you who know a lot about RFCs and how to parse the dates out, you'll notice that that's actually a correct date. It has one comment, a 0. But what is harder to spot is that last modified is supposed to have a dash in it. This site wants to be sure to close its connections, which is good. It's always important to close your connections. And this other site wants to let us know that length is 190,000 bytes, which actually has two different problems in it. Number one, there is no header called length. And second, I just went to their top-level site, and they sent me 190,000 bytes, which seems excessive. Let's take a look at how you can actually use strongly typed headers, what the code looks like. If I'm making a request and I want to set my host name, you might think host, well, how can you misspell it? It's 4 letters long. It's host, H-O-S-T. But the problem is with the encoding. If you have one of the modern international domain names, you've got to set the right encoding on that host header. We handle that for you. You just provide us the strongly typed object, a host name object. You're guaranteed that it's the right kind of host name. You're guaranteed it's correct because we will encode it correctly for you. And that means you don't have to read the RFCs on host names. Content length. Now we're looking at something coming back in from the server, and we want to look at the content length because we want to, say, make a buffer that's the right size. Do we really want to paw through the whole content, through all the headers, looking for the word content length? And then do we want to parse that value out? Remembering to parse, by the way, is an unsigned 64-bit int, because if you parse it as a signed 32-bit int, if they give a content more than 2 gig, you will have errors and issues with your code? No. We parse it out for you. We give it to you as a strongly typed. We give it to you as an unsigned int 64 automatically. That's what the ulon length is. You might notice on there it says response.content.headers.content-length. Cool, that's my header type, .value. It's a nullable type. That means that if it exists, it'll have a value for it. If it doesn't exist, we won't have a value. It'll be null. Oh, the other thing to know, by the way, let me go back a moment. On content length, just because there's a content length on the wire doesn't mean we will give you a content length. And the interesting reason for that is that the content length on the wire is the length on the wire, but it could be compressed. We do automatic compression, of course. It might be compressed on the wire, but we won't know the final length until you uncompress it, but you uncompress it long after we've already given you the headers. That means that if there's a content length on the wire and it's compressed, we actually won't give you the content length, at least not in 8.1. And lastly, let's take a look at last modified. There's also a response coming down from our server. They might give us our last modified. Once again, do we want to paw through all the headers? No. Do we want to parse a date, time from a server? No. We will parse it for you so that you don't have to do that parsing. You don't have to read those RFCs. Not only that, but when we provide that object, we provide it in the right in the right format, with the native object type, depending on the language you're talking to. In C#, it's a date-time offset. In JavaScript, it's I've got a cheat sheet, a date. And C++ is actually a Windows Foundation date time, although it's nullable, so it's in a little iBox object. We can also handle custom headers. In this case, I've got a server. The server is demanding that when I make my AJAX calls, when I make my web calls out, it says, hey, you got to set this xRequestedWith value. You got to set this xRequestedWith because I'm going to return different data depending on what you say on it. And so you got to set it in order to match what your server needs. We can handle any kind of header. You just add it with this try append without validation. You can also list all headers. When we list all headers, you just grab your, in this case, I've got a response object. I can just take my response object, grab the headers value, loop through them all, and print them out. But the one subtle thing that you need to know is that we take the headers and we actually divide them into 2 categories. One is that if you're dealing with content, a content object, an IHB content object, then those headers are separate from the request headers. So if you want to look at all your headers, you've actually got to do 2 loops. One through your response object or your request object and look at those headers, and then your request or response content that also has headers built into it. Reason number 3, we got cookies. You can list them, you can set them, you can delete them. If you're a C++ developer, you'll say, well, of course you can. C++, XHR2, COM object. If you're a C# developer, you've always been able to do this, albeit without saving them from session to session. If you're JavaScript, though, you should be going, wow, finally, I can mine dub-dub-A. I can easily look at the cookies that are coming down. Here's a quick code sample on how to set a cookie. Now, this is the first time you've actually seen some of the power of the HTTP-based protocol filter. Remember, on the object model, and it's on your posters, on the right-hand side, there's a little gear on it. The gear's not on your posters, but it was on the picture up here. There's a bunch of settings on it, and one of those settings is the base protocol filter cookie manager. The cookie manager manages the cookies for your app. You want to set a new cookie? Well, you just make one, new HTTP cookie. You give it a name of the cookie. You give it the domain for the cookie, which is not a host name because it's subtly different from a host name because it can begin with a dot, which host names aren't allowed to. And then the path, which in the case on the sample is a slash. And the slash means, of course, all the paths inside my site. I set my cookie value, and then cookie manager set cookie. Once I, of course, have created my base protocol filter, I should actually use it. So I'm setting it up so next time I call HttpClient, that's the very bottom line on the screen. Next time I make my HttpClient, I'm going to pass in this base protocol filter that I created. So I use this base protocol filter when I make my requests. Now, once I set this cookie, what that means is that every subsequent request I make going out, which is to example.com or a subcomponent of example.com, and in any of the paths in example.com, because that's how cookies work, will send this my cookie name with my value. And let's see some running code for that, too. And if we can switch to the demo, I get to do more flippy things. There we go. There's our old demo. There's our old code. This is the new one. The demo number 2, I decided in the word cookies, that's Unicode character cookies. And the smiley face is actually the shockingly precisely named Unicode character face relishing delicious food. And what I'm going to do in this demo is I got a URL, and it's going to be bing.com. I'm not going to show you the response from bing.com. I'm just going to make the request, and after the request comes in, I'm going to loop through and say, hey, for bing.com, what cookies do I have? And this is my code to do that. I'm going to make up a base protocol filter. I'm going to grab the cookie manager. I got it in my URI, which I know is bing.com. And I'm going to call get cookies. That's just going to make me a list of cookies. I get to iterate through them. I get to print them all out. So that's what the log statement is, log, cookie.name, cookie.value. Each cookie contains a bunch of information. I'm just doing the name and value. And let's take a look at watching that work. So I'm going to do my get. And Shazam, there's a bunch of cookies that either bing.com gave me right away, because I just made the call, or that had come earlier, because this includes all of the persistent cookies as well. All right, now let's go back to the slides, and we're going to talk about cache control. So we all know if we do anything on the web, anything with a web browser, we know that HTTP has caching built in. And it's really powerful and really useful. And we use that inside of our own programs. But sometimes we need a little bit more control over how the cache works than what you would get with just a plain old call. And this is new for everybody. This is new in C++. It's new in C#. It's new in JavaScript. And something that I'm actually really pretty excited about, and solves some problems that we've seen that people have when they make their apps. And the first thing that we want to know sometimes is, well, I made a call, and I got some data, but you know what? I just got to know, where the heck did my data come from? Did it come from the cache, or did it come from the network? And I could start up Netmon, or I could start up Fiddler and sort of trace through it. Or you could just ask us, because we'll tell you if it came from the cache or came from the network. We will tell you in the HTTP response, there's that source field, which you see highlighted. And that source field can have one of 3 values. Now, we're always here from Microsoft. If you call this inbox code, we're always going to set it to network or to cache. But there's some third-party filter stuff, and they might set it to none. If you just new up a response, because you're allowed to just new up a response whenever you want, it'll be, we automatically set it to none. And what are the values? Well, cache and network. And that tells you whether it got it from the cache or from the network. Sometimes, though, we don't want to just look at where the data came from. That's great for statistics. That's great for debugging. But we need to actually control stuff. And the first thing we can control with HttpClient, with the new Windows Web HttpClient, with our new runtime object, is we can control our cache writing behavior. And we do this, once again, on the base protocol filter. And we do this on the base protocol filter in a thing called cache control. And it's in your posters. And there's two values. And the default value is default, which means kind of work like a web browser works. Right? We all know how web browsers work. You send a request out. You get a response back. It's an OK response. It's a success response. And the server gets to set a bunch of headers on it saying, use this. This is cacheable, or this is not cacheable. And no surprise, we kind of honor those, right? Just like you'd expect, just like a web browser would honor them. And that means that the next time we make a request to the same URL, we'll get the same data back out of cache, assuming it hasn't expired. That's the default behavior. That's the behavior you get automatically out of the box. But you get to influence it well. You get to control it some. And the control that we give you is that sometimes a server will return data and say, hey, this is all cacheable. And we as app developers say, no, it's not. It's not cacheable. I will never call this URL again. If you cache this, it's not only just wasting the power to spin my disk drive or run my flash memory, but worse than that, it's going to evict actual useful data from my cache. And I don't want to do that. We see this especially with some of the streaming media things. Right? I'm streaming media constantly. I'm getting more and more data. And some servers are set up to cache all that. But we'll never read it again. Well, you get to control that so it won't cache. If we're doing write behavior, we're going to also handle read behavior. Read behavior is we made a request, but there's already some data in the cache. What should we do with it? And by default, we're going to act really in the same way that a web browser would act. That is to say, I make a request. It goes to the base protocol filter, which then says, is it in the cache? Yes. Has it expired? Because the server told us if it would expire or not. Has it expired? No. Well, here you go then. Done. Got it. But we have two more settings that you can set. And the first one is called most recent. And what most recent does is it does the if modified since connection back and forth to the server for you automatically. That means that when we make our request going out, we make our request, it goes to the base protocol filter, it looks in the cache and says, hey, I got something in the cache. Because if it didn't find something in the cache, we'll just make a request to the server. I found something in the cache, but wait, I'm not going to return it right away. I'm going to ask the server, I'm going to set the if modified since request on that outgoing get request. And I'm going to use the dates that are in the cache already, because I know the dates. And the server will either give me new data, in which case I just return it to you, or the server will say, well, it's not modified, in which case we'll pull the data out of the cache and give that to you. In either case, you get your data, and you get to do it without having to handle all the if modified since 302 not modified stuff yourself. All you get to do is make a request, and you get the freshest data possible. Now, note this requires not only that the server is behaving the way you want it to, it also means that you're doing a couple more network calls than you otherwise would. And it's up to you when you're making your app to decide whether that's a good trade-off or a bad trade-off. And then our last one is only from cache. And only from cache is particularly exciting because it really lets us take our apps and take them from, hey, I can make network calls, to I work smoothly. I have great flow. I am the next level of app because I work really great. I start up fast in particular. And you'll see this for those of you who are running 8.1. If you've used the new Bing stuff, the new Bing travel app, the finance app, the news app, the sports app, they already do this. When they start up, the reason they can start up so fast, they set the read behavior on the first set of calls to be only from cache, which means they get data really, really fast and can display it on the screen really, really fast. And not only that, but one of the real advantages of the new Windows Web HTTP client, because it's sharing cache in your app with the rest of the system, as it were, is we have a new feature in Windows called Fresh Apps. Matt Murray and Sahel gave a talk about this yesterday in this very room in the afternoon. And they talked about how to get that set up. But what it lets you do is even when your app is not running, we will keep the cache up to date for you. That means when the app starts, yeah, it's getting data from cache. It's getting new data from cache. The user's never seen it before, and they're getting it fast. And this really takes us to reason number 5, to another way of writing code better. The HTTP processing pipeline can include your filter code. And in particular, we do this in order to handle some of the common network programming problems, like auth, like retry, like working on metered networks, like a bunch of things. This is sort of a new way to program your code, your networking code, in order to work smoothly, in order to have great flow, in order to provide a really, really great app. And to do so with an absolute minimum changes on your business side. So your business logic stays nice and simple and small and understandable, while at the same time providing a better experience for your users. And so what is a filter? What is a processing pipeline? Well, you remember this from before. Right? That's the HTTP client object on the left, the base protocol filter on the right, and in between the request message, the response message, there's a big gap in between. That gap can be filled with your code. Your code can be injected into a processing pipeline. That means when you call HTTP client, when you call this getStringAsync, it will automatically step through each filter provided. Each filter sees every request message going out. Each filter sees every response message coming back, and they can modify them, and they can short-circuit the whole process. Now, in this case, I'm demonstrating 3 different filters: a retry filter, a metered network filter, and an auth filter. And the reason for those filters in particular is that these are the filters that will really help you get your code to work great for your customers. It's also the case that you don't have to write these filters. We have them for you. Go out into the samples. Go to the HTTP client sample. We have filters ready for you to drop into your app today that will make your app better. Go into the WebAuth broker sample, and it has filters that will do OAuth 2. Just configure them, and OAuth 2 will just work. Let's talk about some of these filters a little bit. Let's talk about the 503 retry. What is 503 retry? Some of you here have probably done 503 retry handling. Some of you haven't. 503 is a status code sent back by the server when it's willing to give you data, when it wants to give you data, when it's waiting to give you data, but not right now. It's overloaded. It wants you to call again in 15 seconds, 30 seconds, a minute, 2 minutes. It'll tell you how long to wait. Well, traditionally, if you wanted to handle 503 retries, your app logic, your business logic, would have to make a request. Oh, but wait. It can't call getStringAsync because that doesn't tell us the status code. It would have to call getAsync, which means they got to do more work, right? Wrong. You can do it in a filter. In the past, your app logic would have had to call getRequestAsync and look at the status code coming back. And if it's a 503, it had to say, wait a minute, that's not the data for me. I got to wait. I got to actually go through the headers and figure out how long the server wanted me to wait. And then I got to make the request again. That really bulks up your business logic. And that's the last thing any of us want to do. We want our business logic to just focus on our business. We don't want it to focus on just some network conditions. All you have to do in order to handle 503 retry is pop our retry filter into your filter pipeline. When it sees a request going out, because remember, HFilter sees all the requests going out. When it sees the request going out, it just lets it go out. When it sees the response coming back, overwhelmingly, it just returns it right away, because most responses are OK. But when it sees a 503, it says, this response is insufficient. I'm not supposed to return 503s. I'm supposed to wait. And so it will, instead of returning that response right away, it'll wait the right amount of time, send the request again. Now maybe it'll work. That means your app logic doesn't ever need to worry about 503s. Your app logic remains simple and straightforward. The same is true for metered networks. We have spent a fair bit of time and effort on handling mobile broadband for you. Right? A lot of laptops these days come with little mobile broadband chips. They can connect to cell networks. And here in the networking department, one of the things that we want you to do is to be mindful of handling metered broadband networks, and to work a little bit differently depending on whether the user is paying per byte or not, which actually is not dependent on being mobile broadband. There's plenty of dial-ups or Ethernet that does that too. But to be mindful also when you're roaming, to let stuff through. People are paying for their broadband, for their mobile broadband, but only after the users said OK. And in the past, you would have had to put a bunch of code into your app logic, your business logic, to handle that. Well, we have a filter that does exactly what our white papers and our blog posts and I have been telling you to do, which means that you just pop this in and then do a little bit of configuring, of course, and all of a sudden, you're being mindful of your users' mobile broadband. And lastly, there's an auth filter. And this is courtesy of the WebAuth broker team. It's over in their sample, because they do a lot of auth stuff. They know a lot about auth. Not a surprise. There's a security team. They do their auth team. And what it does is it does, for example, all the steps necessary for OAuth 2. Now, for those of you who've done OAuth 2, you know it's not super difficult, but it really clutters up your app logic. You have to decide, do I have an access token? Did I save my access token? Maybe I'm resuming, and I've already got one from the last session, which was only a few minutes ago. Let me see if I can reuse that access token. Oh, and if I don't have an access token, I've got to call the WebAuth broker to the right URL. I'm going to get, depending on whether implicit or explicit grant, I'm going to get either code back or an access token back. If I get a code back, then I've got to call another code, make another web call to the right URL. And that hopefully will get me a refresh token plus an access token. That means that if I have an access token, but it failed with a 401, but I have a refresh token, then I should also make another call. It sounds complicated because it is complicated. But we've put all that into our WebAuth broker sample. We put all that into a filter. You just pop the filter in and configure it, and it should just work. Now let's go back to the demo, because I got a demo of that too. And so here we have live code. And you can see there's a whole list of social websites. That list was actually about twice as long earlier in the week, and then I decided to rewrite my code. There's supposed to be a laugh on that, by the way. You're not supposed to rewrite your code right before you demo it. And the one I'm going to show you is Facebook. So you can see it's graph.facebook.com.me. And normally when you're doing stuff with, in this case, Facebook or any social networking site, you've got to do the login and the access token and all that. And so normally it's a real pain. But in this case, this is really indicative of what my actual code is. This is my business logic. I'm just going to call getStringAsync. Do any of you see a WebAuth broker there? No. Do you see me having to struggle with access tokens and whether they've expired or not and refresh tokens? No. Because up here, when I made my HTTP client, I said, oh, by the way, make me an HTTP client that has that OAuth filter in it and configure it. And what's my configuration data? I'm a PM. I get to do fancy things. Well, my configuration data is say, oh, I got a client ID. I got some URI prefixes. I know where my URLs are supposed to point to. And now let's give it a try. When I press get, it's just going to do this. It's just going to call getStringAsync. It's going to take that result. It's going to pop it up into a blue box. Except it won't. What it will really do, and the red you saw flashing on the screen, and it flashed right by, it's already made the request to Facebook. Facebook has already failed it because my access token was out of date. And I've already now popped up the WebAuth broker, and I can say yes. Login. Results from Facebook. And this could happen quickly and easily. And again, with the absolute minimum of code on my business logic side. All right, let's go back to the deck, please. So I want to talk a little more about what exactly. Back to the PowerPoint. There we go. Let's talk about exactly what an IHTTP filter is. We've seen it in action. What is an IHTTP filter? What can we use them for? I've given you some ideas because these are things we ship today. The retry, the metered networks, the auth. You can use them for all those. You can use them for custom caches, too. You can write a filter that sees every request going out and stops and says, wait a minute, do I already have this in my own database? Because if I do, I should just return it. And that filter can just simply pull the data out, synthesize a response, and return it right away. And the whole rest of the filter pipeline doesn't even know you've done it. And your app logic doesn't need to know you've done it either. Your app logic is immune to any changes you make in your custom caching code. You can use it for logging. And wouldn't it be great to get a log of every single request I've made? Wouldn't it be great to get statistics on how many failures there were and how long they took? Wouldn't it be great if I could just keep that in my app and then maybe send it to me every now and then? We can do that with a logging filter that you would write. There's network restrictions, and you saw the example of a network restriction. Actually, you just saw it flashing by for metered networks. Your security team may have other ideas about what proper security is. Instead of putting that into your business logic, you can put that into a filter. That means that you can verify when you're making a connection to a web service that it's actually a proper connection, for example. Or you have other network restrictions about where you can and cannot use your calls to a network service. You can do it for a retry. We have a filter that shows how to do 503 retry. But of course, as you've all seen, when you deal with any kind of good mail program, any kind of good network using program, what happens on flaky networks? What do we want our reps to work? How do we want them to behave? The answer is we want them to retry automatically. I don't want to press the try again button. And I don't want to press the please reconnect button. I don't want to deal with any of that. I just want my apps to just try again automatically. There's no reason why they can't. And with filters, you can write a filter that does that retry automatically. Lastly, we can use it for testing. And this is a really exciting way of making sure your code is bulletproof. It's a way of doing mocking. It's a way of doing unit tests. As we all know, networks fail. When I make a web request, maybe I'll get a 404. Maybe I'll get an exception thrown. Maybe I'll get some garbled data because I'm behind a captive portal like that is common inside of venues, inside of coffee shops, tea shops, restaurants, hotels, airports. They all have captive portals. And you make a request and it comes back 200 OK, but it's not your data. Your app has to be resilient to this data coming back, to these failures, as it were, coming back. And one way to make sure your app is resistant is to make a testing filter that lets most of the requests through, and every now and then fails. Every now and then throws a 404 or throws an exception. Every now and then just garbles the data or returns as junk data. And you can use that to make sure that your app handles bad network conditions. And you can do that without having the pain and agony of setting up a whole server subsystem on some VM somewhere that you've got to maintain. You can just pop in a filter to do that kind of testing automatically. The other part about testing, by the way, is that filters are eminently testable. It's just a little modular bit of code. It's just a runtime component. That means that you can put it into any kind of test harness you like. It doesn't have to be on a network. All you have to do is send it a request, look at the response that it returns. And so that lets you write your unit test really easily. And let's talk also about kind of what exactly is a filter. Because now we've talked about why you'd use them. I've shown you a demo of how it turns your business logic from a big mess into something small and manageable and just does you get string async. What exactly is a filter? How do we actually write one? The important things to know is that a filter is a WinRT component. That means you get to write it in C++. You can write it in C#. You can, yeah, those are really it. Because it's a runtime component. That's how you make a runtime component. You write it in C++ or C#. But once you have one, you can use it in any language. Can you use it in JavaScript? Yes. It doesn't matter how you got your runtime component. You can use it in JavaScript. Can you use it in C#? Yes. It doesn't matter where it came from. It doesn't matter where it came from. My sample, your code, something you found on the internet. No matter what language you were writing it in, once you have that runtime component, you can use it. And in order to make one, all you got to do is implement the Windows Web HTTP filters IHTTP filter interface, which sounds like a lot, but really, it's just one method, send request async. You get a request in, you got to return a response later on, asynchronously, of course. And usually the way you do it is you have like an inner filter set of things going down in like a pipeline. Plus, you got to do a dispose, of course. How do they get into the pipeline? You put them into the pipeline. Every time you make an HttpClient object, and your app, depending on what you're doing, you might have one that you make at the beginning. You might have dozens or hundreds over the course of actually running your app. You might have one that you reuse for every single request. You might have one per web service you're connecting to. You might have one at the beginning of your app and one later on in your app. How you set up your HttpClient is up to you. But when you actually new one up, that's at the point that you can put a filter in. And that filter pipeline is how that particular HTTP client is going to run. Most pipeline is going to end with an HTTP-based protocol filter. You may have been wondering when I put the first diagram up on the screen, how come that thing at the end is called base protocol filter? Why wouldn't we call it go and get my web stuff? And the answer is because the base protocol filter, it's just a filter from our standpoint. It takes a request, returns a response later on. It just happens to be a filter with a whole bunch of useful code in it that will actually go out onto the web and actually parse stuff and actually return these nice, neat packages to you. Just to reiterate, every filter sees all the requests going out. Each filter sees all the responses coming back. Each filter gets to modify them. I should point out, by the way, it's a 400-level talk. Technically speaking, it doesn't have to be a pipeline. You don't have to have one filter going to one filter going to one filter. Technically, it could be a horrible, bushy, asynchronous directed graph, acyclic graph. Actually, and it doesn't even be acyclic. It can actually have cycles in it. Don't. Just make a pipeline. Because really, if you start making circular references, you will never debug it. So let's do a quick recap. This is our object model. HttpClient is the object you're going to connect to most often. It's got delete, it's got get, it's got post, it's got put, it's got send request async. Send request async being the only method on it that we added that isn't just named after an HTTP method, and is going to be the one that provides you the greatest control over what happens. It also has a default request headers. So if you need to make sure that every request going out has a certain header set on it, you set it right there, and everything gets set properly. There's filters along the way, request messages going out, response messages coming back. I didn't mention anything about that HTTP content. We, of course, have an HTTP content type. If you're doing like a post and you need to send data, well, you'll make an HTTP content for the post. What is an HTTP content? Well, we have this IHTTP content class. And if you have a string, we got one that you can construct out of a string. We got one you can construct out of a stream. We have one you can construct out of a buffer. We also have form URL encoded. We have, in addition, the multipart. So now we're getting to the end of the talk here. We've seen the shared cache. We've seen the cookies. We've seen our credentials. We've seen how that works and how that's new for C#. We've seen our strongly typed headers and how that's new for C++ and JavaScript. And you should already be excited about how that's going to make your code less buggy and more robust, and how you can write stuff in less time because you don't have to ever look at an RFC to figure out how to parse a date. We've seen how to access cookies and shared cookies with a little code sample showing how to list cookies that are coming back. And if you're JavaScript and you've been trying to connect to a service that requires you save a cookie or set a cookie, you should be like, yes, I can finally use cookies. And of course, keeping in mind this is for web WWA apps. It's not for IE. IE, of course, still follows the W3C recommendations for cookies. You can control over the caching and the shared cache and how to inject a code into your pipeline. Now, I've talked to a bunch of you in the audience, and one of the things I hear a lot is a lot of you are also doing server-side. And you may be wondering, what is it that we've got for server-side for you? And one of the things I want to emphasize is the same filter model that we have for client-side is what in Web API, using the system.net HTTP client, those are the handlers over on that particular set of classes. So if you are excited about how easy, how much more modular your code can be on the client side using filters, you should be just as excited about how modular your server-side code can be with the system.net HTTP client. And those of you who've used Web API already have seen the power of this, because all their routing and all their infrastructure, that's all based on this handler model in .NET. But I really want to talk about a bunch more stuff as well. There's more than 5 reasons. I didn't even get a chance to tell you anything about the great HTTP progress we have. We tell you when we're doing our DNS stuff. We tell you when SSL is going. We tell you when we're sending headers. We tell you when we're getting responses. You can get all that data and how many bytes we're sending and how many bytes we're receiving. And it's really cool and it's awesome, and I didn't have time to talk about it. I couldn't talk about our SSL and TLS work, how you can find out what your SSL and TLS errors were, and how you can have stronger security. Well, not enough time. I barely had enough time to tell you at all that we do streaming. We do streaming uploads. If you have a streaming server that needs a stream of data, we do chunked uploads automatically. Give us a stream, we will send it. Same with coming down. If you have chunked downloads, pull it out as a stream. We will stream it down for you. I didn't get to tell you about a whole bunch of settings that's on the HTTP Brace protocol filter. You'll have to find those out for yourself. It's in the MSDN documentation. It's on those posters. I didn't get a chance to tell you about how to actually make your own IHP content and IHP filter classes. I didn't get a chance at all to tell you about how to actually configure an OAuth 2 filter. It's easy. It's straightforward. It's not quite fun. But it is easy and straightforward. And for those of you who've done it and have spent hours or days working on it, those things up there, the last two I did took an average of 20 minutes each in order to get the OAuth and OAuth 2 to work. Server and proxy credentials, stuff that hopefully you never have to deal with. But if you did, we can control the server and proxy credentials. And client certificates, once again, that's for stronger SSL security. Tons of banks, tons of financial institutions require when a server connects to a client that we have a client certificate available. And I didn't get a chance to talk about it. What I would like to talk about is how to get started. Number one, look at the HttpClient sample. It has lots and lots of code in it, lots of information on how to actually use all these classes. And most importantly, it has in the sample a metered network filter and the 503 retry filter. You can take those filters and put them into your code. And because it is a sample, you have the source code. Do they work exactly the way you want them to? I don't know. But if they don't, you've got the source code. You can modify them however you need in order to match the servers that you have and the network conditions that you need to work against. Similarly with the WebAuth broker, it's got an OAuth 2 filter built in. Is it going to work against the server you're trying to connect to? Well, if it doesn't, you've got the source code. You can modify it as needed in order to work against the servers that you have. We have MSDN documentation. Look up, by the way, Windows Web HTTP. It's now getting a little confusing because, by my count, there's now 3 things called HttpClient in MSDN. There's this new one, Windows Web. This is for runtime. This is for Windows 8.1. This is for making an App Store app. It's also for desktop apps. It works on desktop. That wasn't even one of the top reasons. It works on a desktop, too. In addition, there's System.NET HttpClient. If you're doing server stuff, you're using the System.NET HttpClient. And lastly, if you're doing work that requires portable class libraries on NuGet, there's an HttpClient via NuGet that works with portable class libraries. And so that works, I think, on phone. Take a look in the MSDN Windows Store app forum. My team is there. I'm there. I will be looking for your requests. We have resources. The Building Great Service-Connected Apps. That's the one yesterday with Matt Murray and Suhail Khalid. It's a great talk about how to take your app up to the next level. How you can make your app not just connect to a web service, because we're all connected to web services now, but how to make your app start fast, how to make it fresh, how to make it work great. There's building a great authentication experience into your app. You can't see that now because it's going on at the exact same time as this one. Back in 2011, we also gave this thing on creating connected apps on today's network, and that talks a lot about retry and the importance of retry. All that information is just as valid today as it was then. And in addition, it talks about how to connect to mobile broadband networks and the importance of handling metered and roaming networks properly. All that guidance that we gave continues to be the guidance we have today. Similarly, there's a Windows App Developer blog that also talks about how to pick APIs, how to connect to metered networks, how to handle conditions correctly. That guidance is still correct, except, of course, it doesn't talk about the new API. And so with that, what I want you to do next, I want you to find and use filters. Do you connect to a website? You've got to start sending them email. How come you don't have a filter to handle my auth? Are you a library developer? You should be using these filters in order to handle your site properly in the way that you want to. And lastly, you've got to update your code to use the new classes. I want all of you to think about how you can update your code, your System.NET code, your C++ code, your JavaScript code, to use these new classes. Now, we actually have some data from the Bing team. They just converted all their apps. They converted from System.NET. And just like Suhail and Matt said, They just switch their namespaces, fix the compiler errors, and the thing they didn't mention, you got to switch your exceptions from web exception to exception. With that, I want you to also evaluate this session, scan the QR code, tell me how I did. Tell us also what you would like to see out of this API, how you intend to use it. So I'm going to leave this up on the screen so you have time. And with that, I'd like to invite you all to go to the microphones and ask me any questions you have about our new API or about anything else about client networking. All right, we have a question.
Do you have a stock filter for HTTP redirects, or is that handled by the base protocol filter?
Do we have a stock filter for what?
For HTTP redirects, the 300 codes.
Oh, yeah, we do directs automatically. Okay. There's a switch in base protocol filter to turn it on or off. By default, it's on, because everyone wants to do redirects, of course. All right, thank you very much for coming.